All right, so like I said, we're going to do 8.1, the official day 2 of 8.1, because there was a lot in this lesson, a lot, for us to just get started on. So today we're working more with finding the composition of functions. And we have a real world example. Like you guys were asking, how do you use this in real life? And so I did some research and got an example of that for us to look through. Okay, so we're going to pick up with example 4 from the book, doing the exact same thing of using an actual set of values for our f and our g. Okay, and so one of these, like the most common place that you're going to see this, and the example that we have on the back of the sheet, is talking about like composite functions you use all the time, like when you're shopping. Okay, so if you're shopping and like you have a coupon and there's a discount on an item, which one, like in what order would you want them to be applied? Okay, to get the most savings. And so, huh?
Stores don't let you do that. If it's on sale, no coupons.
That's not true. Some of them will still let you do that, but it depends. Or another one is like if you think about Menards, okay? If you go to Menards and you buy something, they're having their 11% off sale, great. But if you spend enough money, you also have the option of you save 11% now, and then you can put it on their store credit card, and you would get so many months to pay it off interest free, or okay, if it's a certain amount. Plus, they also pay you so much back if you spend so much and put it on your card. There are some different options there that you can do as well. So trying to figure out which one is the best option. Okay, but those are a composite function. We just don't view them like that. Oh, okay, there you go. But anyway, so when there's multiple discounts offered for things, and as you're getting older, you'll see more of those probably, like buying a car or the interest rate on a house or just bigger purchases and things. What is the best way to go about doing it if you have a choice? Asking your dad only works while your dad's here. At some point, your dad's not going to be here, right? And then do what? I do have the cubes for it. Yes. Okay, so if we remember, what does f of g mean? F of g of x, right? It is the f of g, that's right, but it's the f of g of x. All right, so there's, if we remember, okay, so we want the x value that's linked to our g first. So we're going to do all of those, or sorry, the x value, right, that links to all the g. So we're going to do 1, 2, and 3. And so maybe that would help if we rewrote this as, well, we want f of g of 1, and then we're going to solve f of g of 2, and then we're going to solve f of g of 3. Maybe that would be more helpful to look at all of them. Okay, so f of g of 1. So when our x, okay, again, we're looking at the x's or the g's here. When our x is 1, what's our g of x value? Okay, so our g of x value is 2. You already, I think you're taking it further. You're giving me the final answer. Okay, does that make sense? All right, so like Ethan, what's our g of x when the x is equal to 1? So what's the y when x equals 1? 2. Okay, so now we want the function of 2. So what's the... Right, no, g of 1. Okay, so g of 1 equals 2. Okay, so but I wanted the function of g of 1. So now I want f of 2. So when f is, the x value is 2, what's the y value? 3. Because the g, okay, so g of x equals the same thing as y. So when we put the number, the g of y we found was 2, we're replacing the g of 1 with the number 2. It really is just a roadmap, like Brandon talked about, you know, kind of pointed out last week. So we start with g as 1. Well, then its y value is 2. And now it's saying, okay, well, when the f has an x value of 2, what's its y value? 3. So we just linked the 1 to the 3. That's all it's doing. It is weird. I can't disagree that it's weird.
Are you doing the opposite first? Because you're looking at 1, but then you're looking at 2. It jumps over to 2, and you look at 3.
Mm-hmm.
So you do the opposite.
Right. Because it's like if I put a... Right. Because like, again, if we look at these as like function machines, if I put a 1 in here, I'm going to get a 2 out. If I put a 2 into this machine, then I'm going to get a 3 out. So the 1 is going to get me to the 3. The 2 is what they have in common in between. Okay, so f of 2 we said was 3. So like Brandon said, the ordered pair here is 1, 3. So that's like the final answer for this composite function. Right. Okay, so for the next one, if we're looking, okay, we want the g when it's the x value is 2. So what's its y value when the x is 2? So we just jump next door. So we find it's f of, so now we want the f of 0. Well, we got to come back here. Where is there a f of 0? Hey, right here. So what's its y value? 1. So this ordered pair is 2, 1. So like in our function machine this time, if we put a 2 in to the g, we get out a 0. And if we put a 0 into the f machine, we're going to get out a 1. I never said you would like it, to be fair. Okay, so let's look at the next one. All right, so we want the g when g is 3. So we're going to put a 3 into the g. What are we going to get out of the g, Ethan? You got it. So now we've got f of negative 2. Okay, if we put, so we get out negative 2 and we put negative 2 into the f machine. What are we going to get out of it? We're putting it into the f machine over here. A negative 1. So this is a 3, negative 1. Good job. Okay, so now we need to state the domain. 1, 2, 3, right? So domain, we use that set notation, 1, 2, 3. Perfect. Okay, so do we need to do the next one, the g of f, or do you feel better? Okay, it's like, or do you feel really good about it? And you're like, no, I got this now. Does the function machine idea help? I don't know what I'm doing. Kind of, okay. So then let's make, so this time it's g of f. And I need a pen. So we're going to put in, we're going to have our g machine, and then we'll have our f machine. Wait, did I do that backwards? I was like, because we got to put it in the F machine first. Duh. Okay, because this is G of F of X, so we have to put it in the F machine before we can put it in the G machine. Okay. So the first one we're going to do then is G of F of what? What's my first X value in my F function? -2, right? That's the first value I can put in is -2. All right, so what do I get out of my F when I put in a -2? I get -1. Okay, so now I want the G. I want to put -1 into my G machine. And what do I get out? Nothing. I get nothing, so it's undefined. Not a 0. Never. It's undefined because I don't have a -1 to put in my G machine. So we just say undefined. All right, Brandon, what would be my next F? It would be 0 that we're going to put in. Very good. So how would I write this, Brandon? Keep going. So G parentheses F 0. All right. Okay, so Brandon, when I put 0 in of my F function, what do I get out? When I put it in the F, what do I get out? A 1. Okay. So then this is G of 1. Okay, when I put 1 in my G, Brandon, what do I get out? 2 it is. Very nice. So then this ordered pair is 0, 2.
We did the F of G, then the G of F, and those are the exact same numbers. We have the exact same numbers out.
Okay. No, you're okay. You're all right. Yeah, no, but I was. Okay. All right. And then, so Ethan, let's have you do the last one. Why have you do it? Because it's good for you. So we've done F of 2, right? This one's done. We've done F of 0. The only X value left to put in F is what? 2. So we're going to put the 2 in the F machine. So G of F of 2. And what do we get out of the F machine, Ethan? 3. Okay, so then this is G of 3 now. We're going to put it in the G machine. And what do we get out, Ethan? -2. Correct. So my ordered pair here is what, Ethan? You got it. Okay, and how about my domain here, Brandon? 0, 2.
Yeah, so example 4.
Yeah, they're the exact same. Yeah, they're the exact same. I had changed it before I printed it off for you guys, or before we went back through it. So, because I just saw it in my notes. So it's just extra practice for that, I suppose. Hopefully that helps clear it up a little bit. All right, so then example 5. We're going back to, given the real number functions, f of x equals 1 over x squared, and g of x equals the square root of x minus 3, write the function rule for f of g and state its domain. Okay, so remember, what does f of g look like? F of g of x. It does kind of look like a headache. I can't deny that. I can't deny that. And so, but this means that the g of x, right, is inside of the f of x. Like this is the f of x right here. So maybe if we say, okay, f of x, and then inside that, we actually have the g of x. And the reason I say that is that might help you think about, okay, well, f of x is equal to 1 over x squared. But I need to put this in for the x value, or
Well,
right there.
wouldn't it be different? Wouldn't it be written differently? Because on 8.1 when we did it, it was the f of g, and then in a different set of parentheses, it was of x, and that's when we set it up like that. But that one just has the f of g. Oh, but
They're the-
also the others with order pairs, these are actual. These are like equations. They're
Right.
not order pairs. So
Right.
that's probably the difference.
It is the difference.
It's not the parentheses.
Uh-uh.
X, it's the, okay.
Yeah.
Never mind.
Okay, so then since I'm saying, okay, the g of x has to be inserted in the place of your x value. So we're going to say, well, the 1 and the squared get to stay. But I got to put the g of x value in where the x is. So this is going to be the quantity of the square root of x minus 3.
But there's no x, then you put g in for that too, so then it would just be 1 over 2. You can keep going forever.
Well, if we had an h, we could have f of g of h of x and put another one. Yeah, I mean, like it could keep going because it's just so composite functions are like, which one do we do first? Like, where do we go? Like, which one do we solve first? So in this case, because g of x is on the inside, like that's the one that we would do first. But this is the stopping point. So at this point, we can simplify. Okay, so what is 1? There's nothing to do with it. Okay, what's the square root of x minus 3 squared? What does that simplify to? X minus 3, because the square root and the squared cancel. So we have x minus 3. That is our simplified answer. And we are supposed to state its domain. So what do we know here? It's not undefined. Good try, though. Since we have a variable x in the denominator, and we're subtracting 3, what can x not be? X cannot be 3. Okay, so that goes with this rule. Because if you have 0 in your denominator, then the answer is undefined.
Because you can't divide any number by 0.
So you could have 3.1, and that'd be fine. You could have 3.00006. Do what? You can't. We are going to leave it as a fraction.
You have to add on that little thing.
Nope, because it would be undefined. Any number divided by 0 is undefined, and we don't want that. We can't have that. We want it to be defined. Now, the tricky part here is this finding the domain concept. Okay? And the reason I say that is let's think about the domain of the g. Okay? So we use set notation so that x such that x. What could x, so we said here x cannot be 3 because we can't have 3 minus 3. But, so what do we know about the g? Because 3 is the key, okay? Because we have this part here, so that's our key to it. We just need to know, is it got to be less than, greater than, less than, or equal to? What does it have to be? Well, to be a square root, if it's less than 3, would we? So if we had -2 minus 3, that would give us a square root of -5. No, not there. I'm just looking at G. You're right. There's no square root down here, but I'm looking at the domain of G first. Okay, so we can, because I want to talk through like how we write, like where these domains come from and like why they're there, which ones make sense and which ones don't. It's true. I just want to torture you. So this would equal 5i, but we're dealing with real numbers, right? Given the real number functions. Okay, so he said it has to be greater than 3, otherwise it would be imaginary. Can it be 3? Why not? It is not. But, okay, so 3 minus 3 here is 0. What's the square root of 0? Okay. No. Wait, what was the answer of it? The square root of 0 is 0? It didn't tell you it was a syntax error, undefined? So, right? So this one would be greater than or equal to 3 if we were thinking of it. Okay, so that's it. Like and that's why we're kind of splitting hairs here. I want to make sure you understand, because if I tell you why, but you're right, the domain of the f of g. Right. So this one is so very similar. The domain of f of g is x such that x is greater than 3. Because, like you said, if we end up with 1 over 3 minus 3 and we get 1 over 0, that is undefined. So this one is greater than 3 because we have to take f and x into consideration together. Where this one, like if we were looking for the domain, we're focusing on this part only. So I'm just making sure you understand, like pay attention to what the question is asking, like which domain. Okay, so if we look at f, are there any limits to f? That's why I didn't look at it, but fair enough. Come on, erase. 0 can be squared. So are there any limits to that one? Why couldn't it be 0? Okay, so here, x cannot equal 0. Good. So then what does that mean about the domain? Okay, x such that x is, does it have? So 0 is less than x, or x is, hold on, x is greater than 0, or x is less than 0. That's true, but that doesn't really reach set notation. Yeah, like set notation uses the No. I wrote 0 is less than x. Sorry. 0 is less than x and x is less than 0. But this says if you read it from x, this one is saying x is greater than 0. Or x is less than 0.
Well, also, if you read it left from right, you just have to break it into things. So 0 is either less than x or x is less than 0. That's the left from right. But no, it's not. 0 is either less than x, so that's saying that x is greater than 0, or x is less than 0, which is saying that x is below 0, which is basically what you're saying is as long as it doesn't equal 0, then it's fine. That's what that's saying, because it's either above 0 or below 0. not equal to it.
Right, so this is saying 0 is less than x. Okay, so 0 is less than x. Or x is less than 0, which is why I say, well, if you read it, that's the thing. We can flip these and read them from the other direction, which would say x is greater than 0. So x is greater than 0 or x is less than 0. A lot of people don't. But that's
It's an easier way of writing it, because otherwise you'd have to put in 2x.
it takes less time to write it, and it's it's a well, it's called, I was like, we have intersections and of functions and unions and things, and so that's where it comes in. Like, it's a big thing in algebra that we spend a lot of time doing in Algebra 1. It never will, though. Then you could live on a different system, like, where you don't have to pay for anything. Like, everything's communal. I don't know. It's hard to say. But even when it comes to bartering, there'd probably be something there. Okay, so a real life example here. Addison has a $15 off coupon for an electronics store and also receives an 8% discount as a preferred customer. Oh, this reminds me of like Harbor Freight, right? Like they have discounts and then you have preferred discounts and then you have, like if you're a preferred member, you get a different discount and then you also get coupons and all the things. Okay, so write cost functions modeling the effect of both the coupon and the discount on the price she pays. Then write separate composite functions modeling each possible order of applying the reductions. Use the composite functions to determine which order results in a lower price when she purchases a $200 wireless device. Okay, but we're supposed to write cost functions modeling the effect of the coupon and the discount, and then write separate composite cost functions modeling each possible order of applying the reductions. Okay, so cost functions. She has a coupon. She has a discount. All right, and then we also have the actual cost of the item. So we're going to say that X equals the $200. Okay, that's our wireless device. What would her C of X be? How would we calculate that if she was doing the coupon? Let's say the C is the coupon. Is that right? $15 off? So it'd be the cost of the item minus $15. Good with that? Okay, so let's do the discount.
Which would be,
let's call that D of X.
0.08. Would be X times 0.08.
Okay, so it would not be X times 0.08. It's a discount.
Yeah, but you're still
If you multiply by decimal.
So 200 times 0.08 will get you 8%.
8% of the cost of the item.
Yeah.
But you're getting an 8% discount. Okay, but see, that's it. We're subtracting that away. Okay, so how are you going to write that in one equation?
Oh, so it would be X minus...
Parentheses.
No, it would be X... Well, sorry, go ahead.
It'd be parentheses X times 0.08 plus parentheses minus
X.
Okay, so here's the thing.
X
This is your
minus-
discount.
Yeah.
And this is your cost of the item.
So it's X minus the quantity X times 0.08.
Okay.
Yeah, head to head.
Oh yeah.
Okay. So we have the cost of the item X minus the discount, which is the percent times the amount of the cost of the item. Okay, so because unfortunately in subtraction order does matter. All right, so X minus 0.08X. Do what?
Get a negative number. They have to pay you for the thing you get.
That would be pretty awesome.
That would be fair.
Okay, so we've got I don't know if I want to do that or not to you. It would be easier, but okay. Well, so here's the other thing you can think of. Instead of thinking of this as a discount, right? We're taking 8% off of the item. It might be easier for you to think of, well, how much of the item is staying? Okay. So it's an 8% discount. Okay. So if you have, it's your item is $100. Okay. What's 8% of $100? What was it? $8. Okay. So what's $100 minus $8? $92, right?
So
You fair with
this
that?
one, since it's 200, you can just automatically.
Well, what I'm saying is, just a second, is instead of writing your equation like the cost minus the 8% times the cost, sometimes it helps to be like, well, what percent of my item am I actually paying for? 92% of it. So we could also say that the d of x is equal to 0.92x, 92% of its original cost. So it's less complicated, but you also have to like change your thinking instead of it being, because like you totally understand this and this is correct and I get you're good. I'm just saying, if you want a little bit simpler version, you can say, okay, well, if 8% is what I'm going to subtract, I'm going to keep the 92%. So I could just do 92 times the cost of the item, whichever. Okay. All right. So then we're on to writing the separate composite cost functions. So a composite function is when we're combining these two things together, right? So when we're doing the d of c or the c of d. Or you can say, this is the same thing as the d of c of x, where this one is the c of d of x. So currently, what makes the most sense for you all to start out? Does it help when I say, okay, let's look at the d of x, and then let's insert the c into that, the c of x into that?
Sure. Yeah. So we have our.
Okay, so
0.92.
So our d of x is, which one do we want to use? 0.92x is one vote. Okay. Okay. So we've got our d of x is 0.29x. But we need to insert the c of x into there. Okay, so our d of c of x equals 0.92, and we need to insert the c of x, which is x minus 15. I don't stand in the grocery store and do it. But it's not something in the grocery store necessarily. But, and like, you do it and you don't realize you do it. That's the thing. Like, we're putting a math process to something that you probably do, or at one point in time will do. And how do I do it in my head? Well, because like I would say, okay, well, let's see, if I took $15 off of this $200 item, then let's see, 10%, it would be $185, right? And then 8% of 185, I'd say, well, 10% is $18.50. So 8% is probably like 16 bucks. So $185 minus $16 is $169. Or if I said, okay, 8% of 200 is $16, and I subtracted 16, I'd get $184. And then $15 off of $184 would be $169. So, and like, Without using a calculator, it comes up about the same, like 6 of one, half a dozen of another, right?
Well, like I said, it doesn't really matter which order you do the thing in.
For some, it does. Like you'll see that there is a difference in this one. Yes.
It would be better to get the 8% discount than the $15 off, and there would be a difference in the price.
Mm-hmm.
Because if you think about it, if you're taking 8% of a bigger number, that means it's going to be taken more off. If you already take the $15 off, and 8% of that smaller number, you're not going to get so much off. So it makes sense to get the discount. So you can just do that in your head without knowing what the number actually is. You can already tell. It's like, oh, well, that's going to be less.
Mm-hmm. Also accurate.
I'm still saying, though, you don't get to choose when you're at the register which one you apply first.
No, and this is just one example. Like, this is just one example of how you can use it that's very relatable. Like, you have been shopping, you have used coupons before, you've gone shopping where they've have discounts. Like, for you as a high school student, this should be very relatable, like, when it is used. Versus me saying, oh, they use it in engineering to do this, 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 or this, and you have no idea what I'm talking about. So, we need to finish this problem before I let you go.
You just need to plug in.
All right, so 0.92x minus 13.8 if you distribute on the, and then you plug in the $200.
Can we plug in the $200, subtract by 15, and then multiply by 2? Can we plug in x before we distribute it?
You could have, yeah.
Okay.
Yeah, you could have plugged in x there. Yep, and you get $170.20 on this side. For writing your C of d of x, you get 0.92x. Let me redo this. It won't erase.
How much is it?
Then minus 15, which ends up giving you $169. So which one is cheaper?
CFD.
Is it really that much difference?
Does it matter if it's that much of a difference? Like, math is not necessarily about all that. We've talked about before, like, math is about the process. Like, putting a process to something that you do and following the order of doing it. So it is the cheapest when the discount is applied first.
Are we doing all the homework?
Yep.